Hi everyone, I hope you're having a great time and I'm glad you're all here with me to discuss how we can enhance the user experience in a digital world. So we'll quickly go through what I'm going to discuss in next half an hour. So I'll quickly share on what is the agenda for today, why we are all here, and how user experience goes directly with the day-to-day work that I do as a data scientist. And as part of that, I'll discuss about information retrieval as one of the techniques, some key concepts around it to set a background so that I can, finally conclude it with BM25 algorithm. So that's going to be the main takeaway from this talk. And let's get started. Okay. So we are all living in a digital world, and perks of it is that everything is literally a fingertip away. And when we say that, the most common example that we all experience in our day to day lives is Google search, the World Wide Web. So, what happens is that you type a query into the search bar, and there is output is the list of documents or maybe the links or something which you are looking for, and they are appearing in a certain manner. It's rank ordered in a way, right? So what we and when I explain it like this, it might look a little dry. So I'll give it a, I'll explain it with some example, and I'll keep doing that throughout rest of the talk so that the we are able to build the intuition that is needed for us to understand the algorithm. So, for example, you're a book reader and you walk into a bookstore and you're looking for a specific kind of books, right? So, you explain it to the bookstore owner, for example, in an offline setup. You explain it to a bookstore owner that I'm looking for a specific book, which is maybe, and then you start giving the specifications and the requirements that it should be of a certain age group, and for example 5 to 10 years of age group, and the genre should be fiction, and it should not be very big, it should be a beginner friendly, and those kind of details like which language it should be in, and all. And based on the exhaustive information that you pass into the bookstore owner, the person finds out, because they're expert in that field and they know how things are organized, they'll share some sample of items to you, right? Some sample of books, and based on those, it becomes easy for you to, rather than search to the entire bookstore, out of those 50, for example, the books that the owner thinks might be of interest to you, they present it to you, and based on that you pick the one which is of high relevancy to you. So with this example, in an offline mode, now we'll go to the digital world online mode. So the same kind of things is happening. This was an analogy to make sure that I can explain that we still, on online mode, we have a requirement. So those requirement and the things that I'm looking for, which is of interest to me, I type about it, encoded in a way, I would say that it's a query which is capturing the intent. I type it in the search bar, and outcome, for example, there's something that happens inside, because bookstore owner is now not available in an online mode, right? And my the search space is also not just limited to books. There are n number of things available in web, and I want to look for a particular thing, right? And the output is also again something which I'm looking for. It should be ordered in such a way that what I am looking for as a user should appear at the top section of it. That's precisely what this slide talks about. So what I'm looking for here is that my experience can be enhanced, and how. So the document and the item of interest that is of high interest to the user, it should appear in the top section, and that what in other words I can say that it should enhance the search relevancy. These words and all, don't bother about it. I'll keep explaining them throughout the talk, and all the explanations will come forward. So just stay tuned. And the last definition I can say is that a person wants to interact with the system and access a pool of resources in a more efficient and effective way. So at the end of this entire journey, what we have is a happy user, right? All right. So it would again go dry if I'll not take a couple of examples. We would be thinking, what is query, what is relevant, what do exactly type in, and what kind of results do I get? So based on this, for example, there's a catalog could be of entire things. Like I mentioned that we are not limited to books, right? So you can be looking for anything. So blue t-shirt women. This is what I typed in as a query. So that goes as an input, and something happens. You can assume that there is some machinery which is outputting the kind of output that is listed here. So we can see that it is for a specific gender in the blue color that we have listed. So that works well. Now, if I add more specifications to it, now I am interested in specific polka dot blue t-shirt women. So I add these things in addition to the earlier requirement. And so I start seeing the results are changing. Couple of more examples. You are no more restricted to polka dot. You're looking for some t-shirt which is having something printed on it. You pass in your intent to the computer, and that's how the output looks like. One more. If you're specifying long sleeves, it should give a blue color t-shirt for women which is having long sleeves and all, and the output is accordingly. All right. So whatever I've said, the context so far is effectively a process through which we assume that there's a huge corpus of information lying somewhere, and there is a process that goes behind with which I can access I can access those information in which is relevant to what I need. So basically, there's a set of input that I pass to access the information which is lying outside in a huge corpus, right? So there needs to be that inside machinery that I mentioned, which is what I'll be explaining throughout the talk. This whole process is called as when I'm trying to retrieve the relevant information. This is called as information retrieval. And like I gave an example that we see in day-to-day life, what we want is something which is, just look at the highlighted words. What we want is something which is very immediate. I don't really want that if the corpus is huge, is the pool of resources across which the search has to happen, it can take its own sweet time. That cannot just happen. So I want it in a, like I mentioned, a fingertip away. So it should happen very immediately. And what I want is an accurate list of relevant documents. Accurate, what is relevancy and what is the list of documents that would be outputted. I'll discuss in just few minutes now. And it should happen when I'm hitting the query in the search engine. So that query is a very essential and core component as a starting point of this entire process, right? So search can be based on full text or context based. I'll talk about full text now. So full text does what it takes all the words in the stored documents and tries to match it across the search query. So if we think of it in a brute force manner, it is more like I have n words in the query. And you can call word interchangeably with the terms, right? So n terms here, and there are a lot of documents in, and there's a cross product of it happening, and then based on that, I'm just trying to see what is the best document suited to the kind of query that a user has inputted. So it might really work well till you're limited to very small set of documents, but nowhere does it kind of cater whenever we have a large set of documents. And add to that, even the search queries are not limited to a particular length, right? So it can go up to any length when a person is trying to express what exactly is the requirement. And that's precisely where we'll talk about indexing and searching. Indexing. So I'll start with an example, which is like I write blogs a lot, and just let's take an example that the latest blog that I wrote about is talking about accountability aspect of ethical AI. So I'll tell what all happens during this process and how I want to set the intuition for the indexing itself. So when I'm about to submit that article that I've written, the basically on the platform I'm asked to give a certain tag or a label to my article. So what I do is I label it with AI/ML, and then I give the ethical AI as a tag. One is governance, and another is maybe accountability, and then I submit it. So what happens is, if let's just think from a user perspective, that if I want to look for a certain information, I know that the ethical AI accountability aspect of ethical AI, I can find it under. First is the bigger umbrella, that is AI and ML. For example, there are thousands of articles on AI and ML. Within those thousand articles, for example, 200 articles talk about ethical aspect of AI. So now my search further reduces to it. It is talking about AI ML and specifically on the ethical aspect of it. And within ethical AI, I'm concerned about accountability as one of the pillars, which is explained in detail in a particular article within those 200 articles, right? So it is like maybe 50 or 20 are talking about. So now I am limited to just going through those 20 articles, and that's how reduces my time a lot. So that's one example to explain. And what I'm going to tell now is, for example, we read books a lot, and towards end of the books, we have an index. What it does is all the key all the key text in the book, they are listed towards end of the book in the index, and what they give is a page number. So if I'm, for example, again taking a article example, I'm looking for an ethical AI accountability aspect. So what I do is I look for accountability word towards end of the book in the index, and maybe, for example, it is saying that this particular word is listed or maybe is written in the book at these 5 pages, and those page numbers are given to us. So I go back to those pages, and maybe for all those 5 pages, accountability has been talked about in general, like the ownership or something in general, in 3 of the pages, and those only 2 pages out of the 5 listed in the index are talking about it in terms of ethical AI. So that's what index is. So indexing is basically, now if I'll explain through the definition that I've written in the slide, it says that you need to scan through the text of all the documents and have a list of search items. And these search items is what is basically the list that we have prepared becomes the point of reference for you to search upon. That's where we are basically looking for the information that we are requiring. So that's about full text search. Okay, so we would be thinking that, if a bookshop owner can do something, and what could be the possible issues about it, and why does this need a discussion? And it might be something really simple, and it can be done quickly because a human can do it and we can imitate it, and there must be enough algorithmic development around that. Let's talk about the issues and we'll understand how. So the complexity starts coming into the picture when we are not limited to a small space. We are talking about a lot of content that is available on web, and with that comes that a lot of people are accessing it and trying to access that resource by forming queries in multiple ways. So it is not limited to a particular pattern that people follow. And on top of that, there is a source which says that on an average, people try to capture their intent using maximum of, on an average, 2 to 3 words. So then it becomes difficult to know what exactly you are looking for. And we don't really want to take long time on giving the output. So it's like the response should be really fast, which means that there needs to be an efficient way of looking through those documents. And not all documents are same, because some can capture more information than the others. So the call to that we need to take here is which ones to index. Okay, so I think key concepts I'll quickly walk through. Query, we understand by now that it is a search string, which is essentially asking the computer that this is particular thing that is capturing my intent, and I'm looking for this information. Ranking is when we do when there is an algorithm behind the scenes. The way it is working is that it is not actually towards end of the whole process point us to a single document saying that this is what we are looking for in ethical AI, again with the same example. So it is going to give a list. So when I have a list of items or maybe a set of documents, right, then I need to know that which one is of high importance and which is matching my requirement the most. So it has to be rank ordered and sorted in a certain manner, right, which is with the highest relevant one coming in the top. Term frequency and inverse document frequency. This is TF and IDF. This sets a very important component of what I'm going to discuss in DM25, which I think most people are really aware of. I'll give it a little background. Is term frequency is a particular term that I've captured in the query, how many times it's occurring, that query keyword is occurring in a particular document, the frequency occurrence of it. And inverse is that if the word is too common and it's occurring across a number of documents, then it needs to be panelized, and that's where the IDF score comes into the picture. Okay, like I mentioned before, relevancy, accuracy, all these metrics I'll discuss. So that's what I'm going to explain here. Precision and recall. So I'll first explain what this picture tells us. So in this circle, what we can see is towards the left side, the left semicircle is the results that is actually shown to the user. So those are the returned results. And these are the ones which are not been shown. So basically, we can assume that this is the entire universe in which we had we are kind of searching which one to be outputted, and the algorithm decided the left semicircle is what should be shown to the user. Right? It's a toy example. Now, the green ones are the ones which are matching the user's query. So they are the relevant ones. And the red ones are not matching with what the user has given as a requirement. So precision is that out of all that I'm showing to the user, which one is relevant. So all the results that have been retrieved here, as shown in the formula here, the relevant results retrieved is one, the green that we can see in the blue semicircle, out of four, for example, 4 total results. So that becomes precision of 1 by 4. That's 25%. Excuse me. And recall is, for example, there are total in that universe in which the query was hit, right? For the corresponding there, we had 3 relevant results, but out of 3, we could only output one. That this one is the only thing that is shown to the user. So there's one dilemma that always comes with precision and recall is that if you want your retrieved output to be increased, like the relevant one, the one that is shown with the color green, if I want those to be outputted more, there's this recall problem happens is that in an effort to retrieve more documents, what happens is irrelevant also get accompanied with it, and irrelevant means that they are not what were expected, which lead to increase in false positives. False positives, what they happen in, they kind of drop down the precision. So that's the call we have to take always, whether to show more results or show the ones which are more relevant. So that here comes the important part, a BM25, and don't get intimidated by the whole formula written here. I'll walk through each component of it, and towards end of it, we'll be in a very comfortable position to understand what is BM25. This formula I'll keep showing throughout the slides multiple times, so that we get more comfortable and acquainted with it. And during those slides, I'll also explain how TF-IDF, what benefits BM25 has over the conventional TF-IDF, right? So let's start with the first one. So whatever is in this numerator and denominator towards the right side is basically the TF component, which is term frequency. And within that, if we look, so this F of Qi comma D, what it tells us is that ith query term, Qi is the ith query term. So how many times is it occurring in a document D? So the frequency of it, right? And when we have talked about term frequency, there is a component which needs to be multiplied. So basically, IDF for a particular ith query, it tries to normalize the impact of it. How does it happen? Again, I'll explain with the example now. Okay, so the example, let me just tell the example here. So Q0, for example, if I'm only typing hello, then Q0 is hello. And if the search query looks like this, then Q0, Q1, Q2, and Q3, all these things are being put into the formula for I from 0 to 3, right? 0 to 2. So 0, 1, 2, 3, yeah, 4. Okay. So what we see here is, so I'll explain about IDF first, then we'll talk about multiple parameters that the formula entailed, right? So in inverse document frequency, basically tells about how frequently the terms actually occur throughout the set of documents, and tries to put a penalty on the more common words. And how does that happen is that, for example, I and M. So in the example that I've shown before here, hello, I am Vidhi. So in that, if for example I and M, they occur very frequently. I hope you also agree, right? So if they appear very frequently, let's take an example that this is a formula for inverse document frequency, IDF, where doc count is the number of documents containing it. So for example, we have in our corpus total 6 documents, and how many of those documents have the term that I'm looking for. So it is basically, for example, in cases of I and M, it's appearing, it is such a common word that it is appearing across all the 6 documents, right? So when we do this calculation, we just need these two as an input. My corpus is of 6 documents, a very small one. And out of that, when I look for I and M, almost all the documents, so, or 6 out of 6 documents are having it. So the whole calculation gives me a score, which says that it's putting a penalty saying that I and M, they don't really contribute. So it's not acting as a good signal for me. Okay, so next I take is hello. So I and M, they occur very frequently. Then I talk about hello. So for example, hello occurs in 2 of the documents, and the score we can see is little more than what was it for I and M. And the word, for example, Vidhi, it might be a rarer word. So it is exactly occurring in just one document out of the corpus of 6 documents. So when I do the calculation, it appears closer to 1.3. So what we are effectively doing here is we are developing a mechanism in which if a term is rarer, then the calculation that comes out of this formula, it gives a higher multiplier. So what it does is it gives a more contribution. It contributes a little more for that particular term to the final score. Okay, so again, I'm showing this formula again so that by end of it we become comfortable. We have talked about IDF, we've talked about term frequency. Let's talk about K1, B, and the document length. So here on this slide, we'll talk about document length. Document length is basically what it is doing is telling what is the length of the document under concentration with respect to on an average length of the documents throughout the corpus, right? So the essence here is that if a document is longer, and that means that it is having more terms into it, how it contributes is it contributes to decrease the document score. Let's see how. So if a document that I'm talking about is longer than the average document length throughout the corpus, this particular thing increases, and because it's in denominator, the impact of it decreases. And the agenda here is to make sure that the query word, if it is appearing, for example, just once in 100 word versus 1000 versus once in a 1000 word document, so it makes a difference. As more terms increase and I'm just able to find it once in a 1000 word, that means that the impact is less. Okay, so the next is parameter B. So B, first we can see that it is a multiplier for the length of the document. So it basically tries to calibrate what should be the impact of document length as compared to the average length. So the higher value tells us that the impact of this particular ratio should be increased in making sure, in contributing more to the score. And if B is zero here, because it effectively eliminates this impact, so what it does is there's no impact of document length on the on the score. Okay, so the last parameter that I'll discuss is K. So in normal TF-IDF, if we'll see, so it is assumed, like in we were talking about term frequency, the more number of times a term is occurring, its impact is more and the contribution is more towards deciding and arriving at a final relevancy score, right? So, but what it does is, so this is the typical phenomena that we observe, the terms that are occurring extra times, they must be adding extra to the score. But what BM25 does is it says that there is a saturation level after which, so for example, if we'll see here term frequency component, right, of BF25, it reaches an asymptote after a certain length. So what it does is that if K is zero, so if we'll observe in this formula, so if K is zero, this entire thing goes away and this becomes zero, these things cancel out. So we are only remained with an IDF component. So it tells us that if the K value and the B, so these are what we have to calibrate. If K value that we are giving is higher, that means that we are giving more importance to the fact that if an instance of a term is occurring more number of times, it should be leading to a higher score, right? So that's about it. I hope by end of it we have understood how we can enhance user experience. Why is it needed in the first place? And one of the algorithm that I've talked about is BM25, and there's a difference in terms of these parameters: the average length with respect to average length, where my document lies, and how much impact or the contribution should this document length have on the final score. And K1 will tell about whether the term occurring more number of times is actually giving a good signal. For example, if you're reading a traveling document, you will get to see travel word more number of times. So mere occurrence of a word which might not be very common occurring in a specific document because it is talking about it as a theme does not mean that it should keep adding on to the score, right? So, and this is again typical term frequency and the IDF component. In IDF, we looked into the formula as well and how we can arrive at a particular query term. So what happens is towards end of it, all these values are calculated for each term, like from I to N. For each term, it is calculated and they're summed together towards the end. And out of this entire process, the one simple search query that we type in the search bar, this kind of calculations that go inside, and for each document we get a score, and for that we decide while we rank order it that which one is more relevant to the query that we have formed. So I hope you've understood it, and if there are any questions, I'm happy to take them.